Okay, so let's carry on, see if Zoom's going to work for us. So, so implementation mistakes you can make is fail open login, where if you just leave a blank or invalid username, it'll cause an exception and be accepted. There's a time when this was true of some of my capture the flag homework assignments. Some students found out that if you just did not fill in any answer, it would take it as correct. So that's rude. And all right, and here, if you have multi-stage logins, where you enter a username and password, then you enter like a CAPTCHA or something, then you enter like a second factor, then there might be some issues here. Now, someone's asking for an example of that. Oh, I've had this happen, where one common thing is you put in something it doesn't expect, like you put in parentheses or special characters in the username. So it is processed, like put backticks in the username or something like that. So at the other end, it's interpreted as an expression to evaluate. Another thing you can do in PHP is you can just put in open and closed parentheses or open and closed brackets. And now your username is not a string, it's an array. And therefore, when you try to compare it to a value, it will always fail because it's a different data type. And I've seen cases where that happens. Putting in some punctuation marks will trick it. And sometimes being unable to compare it will cause an error condition, which will be interpreted as success. Like I say, it happened to me by accident. It's easier than you'd think in languages like JavaScript and PHP for sure. All right, anyway, so if you have multi-stages where you have to put in a whole series of things, then a lot of things can go wrong. For example, why would an error condition be interpreted as success? Oh, I'll tell you why. There was a, what I was using in PHP when I did it, there's a PHP substring command, which is what I was using. If student would put in the answer, I wanted to do a substring to see if their answer was included in the correct answer. And it turns out, believe it or not, that the PHP substring command works like this. If it's correct, it gives you a number, which is the location of the string. If it's incorrect, it gives you a Boolean false. It doesn't give you a negative number, not -1. I assumed it was -1. And so my condition was, if it is greater than 0, you win. Or if it was not equal to -1, you win. And so it would return Boolean false if you left it blank, which was not -1, and now you win. That is like the most perverse command I ever found. It actually returns different data types for false than true. But there are a bunch of situations like that. There's more of them in the C standard library too, where C will do bizarre things, having to do with terminators and strings. And JavaScript is incredibly full of them like that, where the problem is loosely typed languages are full of this because it doesn't understand what data type you have. And when you set it equal to something, in fact, you remind me, I should show you this. If you haven't seen it, there's a fantastic video called What? YouTube. Let's see if I can find it. JavaScript. Yes. Okay, I'm going to put this link in the chat. This is the greatest video you'll ever see. If you haven't seen this video is full of horrible things that happen to you. Let me just play a little bit of it. And
you guys know what WAT means? WAT. Exactly. Let's talk about Ruby. In Ruby, if you reference an undefined variable, of course it name errors, as you would expect. And if you try to assign B to A with them undefined, of course it name errors, as you would expect. And what happens if you try to assign A to A with A undefined? Correct. Nil. WAT. Let's talk about Ruby. Ruby, unlike some other dynamic languages, does not have bare words, so you cannot just type words in and have strings come out, unless you define a particular method missing that does the right thing. And then if you type bear words, suddenly Ruby supports bear words. And in fact, it will even support bear words with bangs in them. And this is not deserving of WAT. This is actually a result of how awesome Ruby is. But if you ever actually do this, then WAT. Let's talk about JavaScript. Does anyone know in JavaScript what array plus array is? Well, let me ask you this first. What should array plus array be? Empty array, I would also accept type error. That is not what array plus array is. Wrong, wrong. Array plus array is empty string. Obviously, I think that's obvious to everyone. Now, what would array plus object be? This should obviously be type error because those are completely disparate types. Does anyone know what this is? No, close. No, far away. It's object. Right, nicely done. Now, of course, because this is plus, so you can flip the operands and the same thing comes out. So if we do, what? No, that's just an object. If you do object plus arrays, you get exactly the same thing, which, as you can see, you do. And finally, the only one of these that's actually true is because you add arrays, you get empty string. That doesn't make sense. But an object plus an object is actually not a number, technically. So this one's actually right. And exactly, right? Like, what is even going on in this lab? I don't even understand what person with a brain in their head would think that any of this is a good idea. Okay. Enough making fun of languages that suck. Let's talk about JavaScript. If I say array.new 16, or just array 16, I get an array of 16 things, which it represents as 16 commas, which is obvious. And if I then join those with a string, then I get the string 16 times. This is actually the only line in this entire presentation that's reasonable. Now, if I take that string and then add a 1 to it, it interprets the 1 as, or casts the 1 to a string, and then we get wat1 a bunch of times, fine. Does anyone know what will happen if I subtract 1 from the string? I'm assuming no one does. I'll give you a hint. Does this help? Does anyone know?
Well, anyway, there are other presentations like that. There are a lot of cases where stupid things happen. And here's one in chat. Going back between Java and Python, yes. Print, yes. Yeah, there's so many problems related to that. Anyway, like I say, this is not as stupid as you might think. How just putting like some punctuation marks lead to something being accepted when it ought to be rejected. Anyway, so if you got multi-step login, like login page 1, 2, and 3, you put your username on page 1, you put your 2-factor authentication token on page 2, and so on. Well, then the user might be able to skip steps. They might be able to skip 1 to 3, or they might be able to do page 1 with their username and page 2 where they put in the 2-factor token and change the username on page 2. So now they're actually getting in somebody else's account and so on. If you don't, you should never trust data that comes from the user, and you should never trust that they're doing the pages in order. And if you ask them the same question again, you shouldn't assume you're going to get the same answer again. All right, and so you might use a randomly chosen question to verify the user. There's a few of these. They'll have like, I know a lot, websites make me choose like 3 challenge suggestions and it will choose one, but you might be able to change it in the HTML field or cookies. You can choose the question, or just try many requests until you get the easy question. And then we can talk about how you store the passwords. When you log in, they have to tell if the password is correct. So the password has to be stored somewhere on the server. It might just be stored in plain text, which is a really bad idea, because then when somebody hacks the server, they get it. And often it's hashed with some miserable hash routine, like one round of MD5 or something, which is almost as bad as plain text because you can try millions of guesses until you get some of the passwords. So when you're deciding how to make your authentication system, the main consideration always is convenience. If you make it more secure, then you make it harder to use. And so you just have to choose what your condition is. If it's just a game or something, maybe it's okay to have an insecure system with an easy password recovery. If it's something really important, then your users will probably have to tolerate more inconvenience. Bcrypt. Bcrypt is what you should be using. Bcrypt or scrypt. That's right. That's how you should be hashing your passwords. Anyway, so you should have a password length required. You should have alphabetic, numeric, and punctuation marks, avoiding dictionary words. This book often recommends automatically generating usernames, which I've never seen anybody do. But what I have seen people do is make your username equal to your email address, which seems like a pretty good solution. Bcrypt and scrypt are preferable because they are much slower to calculate. Bcrypt and scrypt do things like 5,000 rounds of SHA-512 plus a salt. So that's the point. They just are a system. And so the result is it takes a long time to calculate the hash, like 50 or 100 milliseconds. And that means that if you have a dictionary of 1 million passwords, you can't really try them all in any reasonable amount of time. Whereas you can try 100 million passwords with like MD5 or one round of SHA-1. So it makes a big difference. It's not like the underlying technology is different. It's just they're hashed and salted. And I think I got a slide like that coming up. Anyway, so once you got your credentials, you have to use good cryptography like SSL. Never write your own cryptography. If you think you're smart enough to write cryptography, you are wrong. Just get over it. Just use a standard cryptographic system that has been tested by the experts. Don't deviate from that. It never comes out good. And your whole page should be HTTPS. Use post instead of get. Don't put the credentials in parameters or cookies, URL parameters or cookies. Don't send them back to the client, and hash them on the server. And for hashing, here's what you should do: salt and stretch. Salt means you add some random characters before you hash it. And the random characters are then stored with the password in plain text. They're not very secret. And stretched means many rounds of hashing, like 5,000 rounds of SHA-512. That's what Kali used. And you can find it in this file called login.defs, 5,000 rounds. And the Mac uses, I think, 5,000 rounds of SHA-512. That is considered good. The reason you salt it is so you cannot make a master dictionary of password hashes, because every password has random letters added to it. And the reason you stretch it by having multiple iterations of the hashing is just to make it take longer to calculate, so you can't have a big dictionary and try them all. And this is what bcrypt and scrypt do. They use strong hashing algorithms and many rounds. All right, so remember me, you should only remember non-secret items. If you let people store passwords locally, like on your phone, they really should be encrypted with a key that's only on the server. All right. And a lot of people say, force your users to change passwords periodically, but as I mentioned, that is no longer considered a good idea. All right. So if you don't have new users come in, you should force them password change on first login. Yeah, Pepper is an additional secret added when salting. That's right. That's another option. Good. All right. And some people say maybe you should use drop-down lists instead of text fields so keyloggers won't work. I haven't seen anybody do that, but it sounds like a pretty good idea. So validate the whole password, which is the thing that would happen if you hash it. Hey, Corinne, I don't know what you're referring to. Pepper, Macs do not use peppers as far as I know. Macs just use salt and stretching. I've heard of people talking about pepper. I haven't seen anybody use it, but it probably is somewhere. Anyway, if there is any kind of exception, you should just terminate the session and not make the other mistakes we've talked about. If you have a multi-stage login, then everything about your login process should be stored in a server-side object. The server should know they completed step 1, it's time for step 2. They completed step 2, it's time for step 3. So if they try to perform the steps out of order, the server will notice that. And All right, you shouldn't let them change like their username partway through the submission process. And so the first task at every stage should be to verify that all the prior stages have been completed, realizing someone could be just jumping to step 2 or step 3 from nowhere. And you don't give them an error message until they've gone through the whole process, even if the first stage failed. So you don't let them crack one stage at a time. That's why simple, efficient programming, where you just try to resolve whether you're right or wrong as quickly as possible, is not the most secure procedure. All right, so all authentication failures should just use the same code to produce the error message to make sure that the result is exactly the same. And you can use account lockout. Be aware that you can try a bunch of usernames and see when they get locked out. And then you know that was a valid username. So that's an issue. Login attempts with invalid usernames should lead to the same error as valid ones. I see these errors quite often on real servers. Self-registration, of course, is what most people have. You can make your own account. If you let people choose their own usernames, then that is considered a poor practice according to your book, although I see it everywhere. But anyway, the alternative is generate usernames or use your email as usernames. And so you can do a brute force attack at login or password change or recover large password, or really anywhere where the password is used, could be used for a brute force attack. Don't banks log you out after 3 login strikes? I don't know. I know when I tested bank cookies a while ago, banks invalidate cookies after 10 minutes of invalidation, 10 minutes of no activity. And they also lock you out after just a few guesses. I think most of them do. Yeah. All right. So a high security app would disable it after several logins. Yeah. And there you'd have to do something out of band, like call the customer support. That's one option. A cheaper option is just a 30-minute delay. If you guess too many times, 30-minute delay, by then you might find where you wrote down your password, and that way I don't have to pay for help desk or anything. Password sprays are really a big attack. Most common things, you go to like a password dump, and then you just try that password all over the place. Or instead of trying one username and many passwords, you try one password and many usernames. And the point of that is you will typically not hit any lockout thresholds. So it's a problem. And especially if you can get a dump of all the usernames, like City College would be pretty easy, because the accounts for students and faculty are just like the first letter of your first name and the first 5 letters of your last name. And you can just get a directory of all the faculty. So you could easily make a list of all the faculty logins and then just say somebody probably used password 1 or something, and just try that everywhere. That's a password spray attack. They're hard to stop. And all right, so password change, there should be no way to change a username, and you should require the old password and the new password twice, and then give the same error message for all failures. And after you do a password change, the user should be notified that somebody changed the password, so they might notice if it was an attacker changing the password. And for account recovery, you either go out of band and make them actually call up the help desk or something, or email. And once they get in, you send them a time-limited, unguessable, single-use recovery URL. Your challenge questions should be not too obvious. They're pretty weak anyway. And anyway, log all the authentication-related events and protect those logs, and look for suspicious patterns of login. It's one of the most common clues that someone's attacking you. And then notify the users in band of these security events. Gmail is really nice. Gmail tells you the IP address and the general location of the last time people logged in. I often look at mine, and it tells me where I am. And I appreciate that. I can tell if somebody in some other place has been logging in. So this will be the last Kahoot, and then I've got some demos. So let me bring up my Kahoots, which are somewhere around here. Somehow I appear to have lost my Kahoots. Well, I'll open another one. Oh, they're here. Okay, good. 6C. Good logging setup strategies. I don't know a good reference for that. I know you can configure to log authentication failures, and you can even log authentication successes in something like Windows. No, I'm afraid I don't have a good answer for that. But I know when you're setting up web servers and such, you are log levels you can choose for things like Apache. It's a good question, though. It'd be nice to have some logging recommendations, and I don't know a good page for that. All right. I think we got everybody that's coming. All right. So which one might let you in with an invalid or blank username? That's it, fail open. Oh, by the way, Jordan, I think you can definitely find recommendations if you have a specific product. It's just they're all different. So if you Google like a particular product and logging, secure logging recommendations, you'll find tutorials on it. Yeah, okay. So how should you store your credentials? All right, that's it. Hashed, salted, and stretched. Good. All right, so what happens if a user fails at the first stage in a multi-stage login? What should happen? Yeah, complete the process and then show an error. Don't jump to the beginning because then they'll know what part failed. You want to do the whole process and then show a generic error. All right, so what function should use auto-generated usernames? A recommendation from the book, which I have never seen anybody actually use. Not since the days of CompuServe. CompuServe did this. Must be 35 years ago. Yeah, self-registration. I remember CompuServe, everybody just had like a 12-digit number for a name. Anyway, all right. All right, Jeff's a repeat winner. Woot is a new winner. I know who that is from the past. And JC, I think that's Judy, or it could be Jordan. I see Jordan exists. I think I'm going to assume it's Jordan today. And yep, Jordan today. That's what I figured. Good. Okay. Good. All right. So I have the winners. And let me close that. All right. Now I'm going to stop this video and make another one, which is